Professor Stephen Hawking might have died before the James Webb Space Telescope finally launched. Still, due to the vast space legacy of the late physicist, many hours of the new space telescope will be dedicated to proving some of his theories. One of such theories is the very last one Hawking worked on before his death, in which he argued about a multiverse theory that implies an exact copy of you existed in a parallel universe. It is not common that a single piece of scientific equipment will yield so much benefit, but the JWST is already delivering. It has finally proven Stephen Hawking's multiverse theory, which many scientists opposed. What is the Stephen Hawking's multiverse theory? How does it affect you? And how has the James Webb Space Telescope finally proven the theory? Have you ever wondered if there are other intelligent creatures in the universe in places apart from planet Earth? While that may not sound so chilling, what about if there are copies of you distributed around, let's say, the universe? This means a form exactly like you, doing things you would do. That sounds creepy, but the theory has the backing of one of the brightest minds to ever be involved in science, the late Professor Stephen Hawking. He worked on a hypothesis named the multiverse theory that seeks to explain why there might be replicas of you that you don't even know about. The idea that there can be copies of you means there can be copies of everything you know of. For example, a copy of this planet or this star of the solar system or the whole Milky Way galaxy can be duplicated elsewhere. But apart from these celestial bodies, your computer or car may have copies too. Who is making all these copies and how many copies can there be in the cosmos? Are these copies fakes? Here is some historical context. As to the question of whether we are alone in the universe, Bill Watterson has the answer. He said, "Sometimes I think the surest sign that intelligent life exists elsewhere in the universe is that none of it has tried to contact us." Of course, that is a sarcastic, witty retort based on human behavior more than on cosmic truth. But in all seriousness, the question has bothered humans for as long as we've been conscious. According to Michael J. Crow, who wrote the book The Extraterrestrial Life Debate, 1750 to 1900, the philosopher Aristotle weighed in the 4th century BCE, saying a so-called plurality of worlds could not exist because every solar system required a prime mover to keep it going, and could not imagine an infinite number of those. Around the same time, Epicurus wrote a remarkably modern rejoinder to the Aristotelian opinion. He suggested that atoms were infinite in number and argued that there are infinite worlds both like and unlike ours. Epicurus asserted that some of these worlds would sustain life similar to Earth. While these two ancient figures were firmly on opposite sides of the debate, they had one thing in common, or rather, lacked one thing in common. They had absolutely no observational data on which to base their opinions, meaning that the controversy surrounding the possibility of extraterrestrial life raged on through the Middle Ages and Renaissance up to our own time. For example, Cornell professor Carl Sagan, whose public television series Cosmos brought the concepts of astronomy to a broad audience, advanced a principle of mediocrity that echoed the writings of Epicurus. He said there was nothing special about our solar system or plane. There are billions and billions of stars in the universe, with many planets capable of sustaining life and intelligence. Cosmologists John D. Barrow and Frank J. Tipler countered with the anthropic cosmological principle, arguing that even with a universe full of planets, generating life on one is difficult, and it is a big leap from single-celled organisms to large-brained mammals who can debate cosmology. Therefore, we should reserve judgment as to whether we are alone or only one overachieving species among many. You know, Aristotle and Epicurus would be pleased to discover the argument they started continues 2,000 years after their deaths. However, scientists believe we are tantalizingly close to discovering if there are intelligent neighbors in the universe and how close they are to us. The theory is special because it was the last one published by the professor. In fact, that final research from the sharp mind was submitted for publication just 10 days before his death. In the paper titled A Smooth Exit from Eternal Inflation, which he co-authored with Thomas Hertog, a physicist at the Catholic University of Leuven in Belgium, Hawking laid out a theory on the origin of the universe that might settle a few lingering questions. However, despite it being his last work, the paper was actually a final look at one of his earliest theories. In fact, if the JWST eventually helps prove the existence of the multiverse, it will make the scientists behind it likely candidates for a Nobel Prize. However, since Nobel Prizes cannot be awarded posthumously, Hawking would be ineligible to receive it. What is the multiverse theory, and what did the late physicists have to say about it? The multiverse theory suggests that our universe, with all its hundreds of billions of galaxies and almost countless stars spanning tens of billions of light years, may not be the only one. Instead, there may be an entirely different universe distantly separated from ours, and another, and another. In fact, this mind-bending theory suggests there may be an infinity of universes, all with their own laws of physics, their own collections of stars and galaxies, and maybe even their own intelligent civilizations. So basically, our universe could just be one member of a much grander, much larger multitude of universes, a multiverse. However, it gets, as some folks will say, creepier, because the implication of the multiverse is the existence of doppelgangers or copies. According to the logic, if there really are an infinity of universes but a finite number of ways to arrange particles in any individual universe, then the same patterns are destined to be repeated eventually. That would mean that at some incredible distance, there would be an exact copy of you watching an exact replica of this video. And because there would be an infinite number of universes, there would be an infinite number of these exact scenarios, all happening at the same time. The concept of the multiverse arises in a few areas of physics and philosophy, but the most prominent example comes from the inflation theory. Inflation theory describes a hypothetical event that occurred when our universe was very young, less than a second old. In that brief amount of time, the universe underwent a period of rapid expansion, inflating to become many orders of magnitude larger than its previous size. The inflation of our universe is thought to have ended about 14 billion years ago. However, inflation does not end everywhere at the same time. It is possible that as inflation ends in some regions, it continues in others. Thus, while inflation ended in our universe, there may have been other much more distant regions where inflation continued and continues even today. Individual universes can pinch off of larger inflating, expanding universes, creating an infinite sea of eternal inflation filled with numerous separate universes. In this eternal inflation scenario, each universe would emerge with its own laws of physics, its own collection of particles, its own arrangement of forces, and its own values of fundamental constants. This might explain why our universe has the properties it does, particularly the properties that are hard to explain with basic physics, such as dark matter or the cosmological constant. According to some scientists, the biggest piece of evidence for the multiverse is that life exists, particularly intelligent life capable of making cosmological observations. They look at it this way: certain aspects of our universe seem special and vital for supporting life, such as the longevity of stars, the abundance of carbon, the availability of light for photosynthesis, and the stability of complex nuclei. But all these features are typically not the case if you get handed a random universe. The multiverse offers one explanation for why all these features are favorable in our universe, which is that other universes exist as well. Still, we observe this one because it's capable of supporting complex life. However, according to Hertog, Hawking was not satisfied with this state of understanding of the multiverse, so he asked Hertog to join him to try to tame the universe. The pair then worked to develop a method to transform the idea of a multiverse into a coherent, testable scientific framework. Hawking's final paper suggests a framework for understanding the universe that would render the multiverse finite, countable, and subject to meaningful engagement via the tools of science. Meanwhile, it is one thing to have a theory, and it's another thing to be able to prove it. Proving the multiverse theory is a complicated step because of what it involves. The proof requires going back in time to re-examine lots of processes and events that happened before we got here as a universe. When talking about looking back, we are talking about time spans of billions of years down to the Big Bang, as we mentioned in this video already. Where will scientists get the tool that can do this? Astronomers have grown fond of the Hubble Space Telescope, which deserves a place in the telescope's Hall of Fame. The Hubble was launched into orbit by the Space Shuttle Discovery in 1990. It operates in an orbit about 547 kilometers or 340 miles above Earth. It's the length of a large school bus and weighs as much as 2 adult elephants. In its orbit, Hubble travels about 5 miles per second, which is like traveling from the eastern coast of the United States to the west coast in 10 minutes. The sun is Hubble's source of power. Hubble takes sharp pictures of objects in the sky such as planets, stars, and galaxies. Hubble has made more than 1 million observations. These include detailed pictures of the birth and death of stars, galaxies billions of light years away, and comet pieces crashing into Jupiter's atmosphere. The advantage of Hubble being in space is that it escapes the Earth's atmosphere, blocking the light coming from space. This means it has a better view than ground-based telescopes on Earth. Hubble is quite capable thanks to the sophisticated instruments on board. For example, it has fine guidance sensors that lock onto stars. The fine guidance sensors are part of the point-and-control system and to aim Hubble in the right direction. The telescope is so sensitive that it can lock onto a target that is 1 mile away without being displaced by more than the width of a human hair. Once the target is acquired, Hubble uses its primary mirror to collect light. This mirror can collect about 40,000 times more light than your eye. The light bounces off the primary mirror to the secondary mirror, and the secondary mirror focuses the light back through a hole in the primary mirror, and from there, the light shines on Hubble's scientific instruments. Each one of these instruments has a different way of interpreting the light. There are other instruments on the Hubble, but how far can it see into the past? That is the same question as asking how far the telescope can see. Well, the farthest object the Hubble has seen is the GN-Z11 galaxy, which is about 13.4 billion light-years away. So basically, the Hubble saw GN-Z11 how it was about 13.4 billion years ago, and that is the limit of the telescope. The Big Bang occurred some 13.7 billion years ago, which means there is a 300 million year gap between that event and the extent to which the Hubble can look back. That gap contains crucial information. Fun fact, the GN-Z11 galaxy is now 32 billion light-years away from Earth because of the constant expansion of the universe. This is where the mother of all telescopes, the James Webb Space Telescope, comes in. Regarded as the successor to the Hubble Space Telescope, the JWST is the largest space observatory ever built. It has a gigantic sunshield that measures a massive 22 meters by 12 meters, roughly the same size as a tennis court. The function of the shield is to keep heat from interfering with the operation of the infrared cameras. However, despite its size, about double the size of Hubble, the JWST is almost half the weight at 6,500 kilograms. The JWST's gold-plated mirrors have a total diameter of 6.5 meters, much larger than Hubble's 2.4-meter diameter plate. The implication of the larger surface area is that, overall, the JWST will have approximately a 15 times wider view than Hubble. After launching into space, the JWST will orbit the Sun, flying up to 1.5 million kilometers from Earth in temperatures reaching minus 223 degrees Celsius. For comparison, the Moon is 384,400 kilometers away, while the Hubble Space Telescope flies only 570 kilometers above our planet, as mentioned earlier. Because of the huge distance the JWST is located from the Earth, it will not be able to be serviced by astronauts if any faults arise or there is a need for refueling. Thanks to the infrared instrument, the JWST can focus on bright objects like very far galaxies. The job description of the $10 billion JWST is to examine the first light in the universe and the celestial objects which formed shortly after the Big Bang, investigate how galaxies form and evolve, study the atmospheres of distant exoplanets, capture images of planets in our own solar system, and locate evidence of dark matter. Interestingly, Hawking helped develop the theory that led to the idea of infinite parallel universes, that is, the eternal inflation theory, but he admitted he had never been a fan of the multiverse in an interview. He is quoted as saying, "The usual theory of eternal inflation predicts that globally our universe is like an infinite fractal with a mosaic of different pocket universes separated by an inflating ocean. The local laws of physics and chemistry can differ from one pocket universe to another, which together would form a multiverse. But I've never been a fan of the multiverse. If the scale of different universes in the multiverse is large or infinite, the theory can't be tested." Hawking and Hertog relied on string theory, a branch of physics that tries to reconcile quantum physics with gravity and Einstein's theory of relativity. They came up with a new idea of eternal inflation that relies on a boundary at the beginning of time. The idea suggests that when we trace the evolution of our universe backward in time, at some point we arrive at the threshold of eternal inflation, where our familiar notion of time ceases to have any meaning. Starting from that boundary, the new theory predicts a finite structure of universes emerging from the Big Bang. If this theory is proved true, it would suggest that other universes like our own could have emerged at that point, and there could even be primordial gravitational waves that match the inflation of the universe. But this new model is still far from proven, and physicists will need more data and a better understanding of string theory before that's possible. The paper also implies that it might be possible to test this theory. However, the existing instruments then were not sensitive enough to find evidence of this theory, but that does not stop scientists from trying. Physicists could look for evidence of other universes using tools designed to measure ripples in space-time, also known as primordial gravitational waves, that would have been generated by the universe's initial expansion from the Big Bang. Now, you can be sure that if any cosmos theory comes up today, NASA will start investigating tomorrow, so it is not even surprising that NASA has dedicated resources to research parallel universes, and the results are fascinating. The quest for the parallel universe where time runs backward took NASA not into deep space, but the Antarctic, one of the coldest locations on the planet. The project was called ANITA for short, but it means Antarctic Impulsive Transient Antenna, and it was run in conjunction with multiple partners, including the University of Hawaii. ANITA is a stratospheric balloon-based experiment with radio antennae pointed back at Earth to detect radio waves emitted by very rare high-energy neutrinos if they strike an atom in the ice. A radio telescope, ANITA is the first NASA observatory for neutrinos of any kind. Neutrinos are of great interest to astrophysicists as they are the only particle that can reach Earth unattenuated at all energies. This is particularly of interest at high energies where other particles and photons will interact with the microwave background photons, making them unable to propagate and survive over long astrophysical distances. In other words, if you want to see the ultra-high energy universe, you should view it through the light of neutrinos. The ANITA instrument detects these ultra-high energy neutrinos using the Ascarian effect. This effect predicts the production of coherent radio emissions from a cascade of particles produced in a high-energy particle interaction. In other words, ANITA detects a snap in the radio frequencies caused by the interaction of our ultra-high energy neutrino. To detect this radio emission, Ascarian pulses, scientists need a radio-transparent medium for the interaction to occur in, and lots of it since these interactions are rare. Some materials that are radio-transparent are salt, sand, and ice. A fairly radio-quiet area is also required, as the Ascarian pulses are very faint signals. ANITA did detect a high-energy neutrino coming out from the Antarctic ice, and the results have led to a discussion among physicists. Some claim the neutrinos come from a parallel world or universe where time runs backward. However, other scientists caution that there are other explanations for the neutrinos detected by ANITA and caution about jumping to conclusions about the existence of a parallel universe. Of course, scientists have to argue about everything, but we are excited that humans are as close as possible to detecting whether there are other intelligent life forms inhabiting parallel universes. Another person with views on parallel universes is Elon Musk. As the CEO of SpaceX, a space exploration company, it is not surprising that he is a science nerd. He is promoting humans living permanently on Mars, and while it is not likely we will find aliens on the Red Planet, meanwhile, Musk also has some interesting views about the multiverse theory. He thinks we're all trapped in a Matrix-like pseudo-experience. He revealed this on a podcast session with Joe Rogan, who he sometimes hangs out with. According to Musk, the universe being 13.8 billion years old means any civilizations that may have arisen throughout the cosmos have had enough time to hone their technological know-how. He said if we assume any improvement rate, then games will be indistinguishable from reality, or civilization will end. It could only be one of the two. This means we are most likely in a simulation because we exist. He added, I think most likely this is just about probability. There are many simulations. You might as well call them reality, or you could call them multiverse. Musk thinks the substrate, or whatever is powering the simulations, is probably boring compared to the simulation itself. He based this on our experience with video games. Most gamers play because the game is more interesting than the real world. For example, folks who never fought a battle get a kick out of playing war games. Same with racing gamers who enjoy tearing down highways and crashing their cars with reckless abandon because they can't do any of these in real life. So, if we are in a simulation, then we probably live a more exciting life than the folks controlling the game. Remember that the next time you feel bored. Meanwhile, remember Musk and Rogan sipped whiskey throughout the show. Also, at one point, the comedian lit up a joint and Musk took a puff. Marijuana is legal in California, where the show was taped, by the way. Meanwhile, many scientists continue to oppose the multiverse theory, making it highly controversial. Some scientists have publicly voiced their concerns by arguing that it's entirely metaphysical. They claim it's really no more than an idea, bandied about as a handy way to fill some admittedly significant explanatory gaps in our current theories. In this sense, it's used much as the mechanical philosophers of the 17th and 18th centuries like Isaac Newton used God. Moreover, they point out that multiverse theory isn't actually a theory. In the real sense, it doesn't come with a recognized and accepted set of mathematical equations that can be used to perform calculations and make predictions. This means there is no prospect of connecting in any meaningful way with empirical data, at least for now. Another argument is that the theories cannot even be tested, and so they can be neither proved nor disproved. It is argued that, like God or astrology, they do not belong in science. An additional point against the multiverse is that it doesn't have the same status as familiar, well-established scientific theories like relativity and quantum mechanics, something which multiverse theorists allegedly often gloss over. This misleads the public that takes the theories as accepted science, a situation that must surely be ultimately damaging to the public perception and acceptance of its authority. Also, multiverse opposers claim some multiverse theorists appear keen to redefine what science is. They want to junk the scientific method, weaken the all-important connection between theory and empirical facts, pushing the demand for evidence firmly into the background. Let's hear what you think of the